Hello, good morning, good afternoon. This is our eighth session of IoT Live, and today we're going to talk about the WunderBar. So we are with Peter Dverstek from Relier, and yeah, I think you told me you have a bunch of slides for us as well as a demo. So I'm really looking forward to it, and I'll leave it up to you.
All right, cool. Thanks, man. Yeah, so I'm Peter Dverstek. I'm over here in Berlin working at a company called Relier. So yeah, I've got a few slides for you guys. I'll swap over to those and we'll go ahead and get started with it. If you have any questions over the course of, let me go back and share my screen real quick. I didn't do that. If you have any questions over the course of this webinar, go ahead and tweet at #virtualIoT and we'll take care of those questions at the end of the webinar. So here we go. All right, let's start this presenting. So here at Relier, we make a piece of technology called the WunderBar. Some of you may have heard of it, some of you may not have. We like to think that it's going to really change the world of IoT as people see it. So let's talk about what the WunderBar is. The WunderBar is going to be your starter kit for the Internet of Things. It's really targeted towards app developers, and it gives these app developers that may not have so much experience working with hardware or circuitry or things like that, or the sensors in their very raw form, to get real-world data that's sensed from their environments around them into their applications quickly and really, really easily. So let's talk about the actual hardware that we have here. So this is the WunderBar as you would see it when you get it out of the box. It kind of looks, I like to think of it as a bit of a fat tuning fork, and it's made of 7 modules on a piece of PCB. Now each one of these modules, as you can see maybe along the edges, is perforated. So each one of these can be individually broken off. And there's 6 sensor modules that have 7 modules total. Each one of these sensor modules has a different kind of sensor on it. So we have one for light and color and proximity. We have one for the accelerometer and gyroscope. We have a temperature and humidity sensor. We have an IR transmitter and receiver. We have a sound level monitor, and we have what we like to call the bridge module or the Grove module, which allows you to expand the WunderBar by connecting it to a series of sensors provided by Seed Studios, a company I think out of China that have things like breathalyzers, gas sensors, soil moisture sensors, anything like that. And you can also do things like plug Arduino into it or plug a Raspberry Pi into it and kind of make the WunderBar an interesting plug-and-play Wi-Fi shield for those technologies. So each one of these small sensor modules has a Nordic chip on it, which manages the Bluetooth low-energy stack. And now each one of these sensor modules talks with what we call the master module, this large module up here at the top, which also has Bluetooth low energy, and transmit over Bluetooth low energy their data to the master module. The master module also has a Wi-Fi chip on it, and that streams the data up to the cloud and down into your applications. Cool. So let's actually take a look at the path that your data would take from the sensors into your mobile device, your website, what have you. So it starts off on the left here, where the sensors actually sense the data. And as I said, that data is then transmitted over Bluetooth low energy in one of 2 ways. So it either goes to the master module, that large module I pointed out that has a Wi-Fi chip on it. That module transmits the data over that Wi-Fi connection to our cloud solution, and I apologize there. The segment at the top shouldn't say Android device, it should say normal device, but you can access using our SDKs or our libraries that data from the cloud streaming live. Or you can also just directly connect to those sensor modules over Bluetooth low energy. So those are really appropriate for different use cases that we can discuss a little bit later if people are curious, and really give you a flexibility to use these sensors in however way you want. So under the hood, let's get a little bit technical and talk about the path and the different technologies that your data is going to be routed through on the way to your application. So, as we've said a few times before, it starts off with the sensor module, and then in this case, we're going to talk about the data path through the master module, the cloud, and down to your device. The sensor module over Bluetooth Low Energy transmits data to the master module, and then using the MQTT protocol, which is basically a publisher-subscriber as IoT developers. I'm sure you've heard of that. If not, either way, it's just a pub-sub protocol that I would definitely read about. It's very interesting, has a lot of potential for the Internet of Things. And then we go through our MQTT broker through a service called PubNub, which actually transmits that data to your applications. Currently, our SDKs, certain of our SDKs still do use PubNub. We're trying to phase that out and just write our own MQTT client stuff, but most of this still does use PubNub. It's going to eventually make the entire system significantly simpler, more reliable, and quicker when we eventually just write our own custom stuff. But either way, the data along the entire pathway is completely secure, so you don't have to worry about people actually reading your data, unless, of course, you'd like to allow them to, in which case you can actually make your sensitive data public. So libraries and SDKs that we have available to access the data from your WunderBar. We've got fully fledged SDKs available for developing Android and iOS OS X apps. We have a library for the Arduino that allows you to plug it right into the bridge module and just do serial communication back and forth from your applications to Arduino. Plug in a huge variety of sensors there, use it to control something. We have a Python library, a JavaScript library that allows you to do web development, and we also have a library for Node.js. Great. So onboarding is our way of setting up your WunderBar. So when you open up your brand new WunderBar, this is kind of the first thing you're going to wind up doing. Out of the box, the sensors are not linked to the master module. So what onboarding does is actually securely kind of tie those sensor modules into the master module to your account, and really sets up that data flow. So we have apps available for Android and iOS that do this. The only requirement is that your phone does support Bluetooth Low Energy technology. So in a few steps, basically you just press a button on each one of the sensor modules in the master module to put the firmware into what we call onboarding mode, and then the app takes care of the rest of it for you. So it goes through, finds the master module, and then identifies each one of the sensors, assigns each one of those sensors a unique device ID that we'll play a little bit with later during our demo, assigns an ID to the master module, ties those sensor IDs to the master module ID, all that to your account, the master module to the Wi-Fi network, and start streaming data. That might have been a little complicated, but hopefully you've got the idea of how the data stream works by this point. And then you'll be able to see the data live inside of that application, inside the Relayer application, excuse me. So let's talk about a few projects that are already going to Kickstarter or being developed using the WunderBar. So one of the ones we're most excited about is one of our employees here is diabetic, and so one of his concerns is that he needs to keep his insulin within a certain range of temperatures, otherwise it will spoil and become less effective or even downright dangerous. Obviously not something that you want to play with too much. So what he did is he took our temperature sensor and he machined a 3D printed case for it. Now he put it inside that case and then took that sensor and put it inside his insulin pouch. Then he wrote an app for his Android phone that pulls the data from the temperature sensor once every 5 minutes, and if it's too hot or too cold, it gives him an alert. And then he can quickly take action on it by either, going inside to warm his insulin up, or, for example, if he's too hot out of the day with his friends, he can just put it in the shade of a tree or something. It's really quite a simple way for him to not have to worry about remembering to check the temperature of his insulin. He can just let the updates happen to him. So quite a nice solution. And another really interesting one is what's called Baby Beco. And for any of you guys with babies, you might know that a lot of the baby monitors that are on the market are really, really terrible. They're basically just kind of glorified PA systems which allow you to monitor the sound level that's going on in your baby's room, and that doesn't really tell you a lot about what is happening with your baby. So what the Baby Beepo team did is they used a variety of sensors that come with the WunderBar. For example, the accelerometer, the temperature sensor, the humidity sensor, and the sound sensor, and they placed all this in a nice little box and put it inside your baby's crib. And this gives you a much more interesting and more detailed idea of what's actually happening inside your baby's room, if it's too hot for the child, if the child is moving around, and it's much more powerful than just your average radio-based baby monitor. You get updates for this in an application, and if you're away from home, you can see what's going on with your child from halfway around the world if you wanted to. So very cool things. Obviously, Internet of Things stuff, very exciting. So I'd like to take you guys next on a tour of our developer dashboard, which is what you'll be working with a lot when you're working with the WunderBar. So let me open that up. If I go to developer.relayer.io, this is, close our holiday challenge page there. This is where you manage every aspect of your WunderBar, and you can see all of your sensors and your API keys and things like that. So for example, I currently have a WunderBar here that I've named Judge Fudge, and it is, as you can see, transmitting data live. So if I start making more noise near the sound sensor, you can see that the sound sensor is updating itself with higher values based on that information. Or as I slowly move my hand closer to the proximity sensor, you can see that value increasing as well, or you should be able to. There we go, right. And you can even see the color sensor down there at the bottom, which is located on the same chip as the proximity sensor, is detecting the color of my hand. As I put my hand quite close to it, temperature is increasing and the humidity is increasing as well. So this is where you can see all of your WunderBars and the live data that's being fed from them. You can also see your API keys, which are all of your applications that you've created that use the WunderBar. We use OAuth to authenticate you to get your data from your specific WunderBars into the application. So any of you that have played with OAuth, this is where you'd set up all of your API keys for your applications. And this is also where you can find all of your documentation. So this is where you'll find your getting started, documentation on Android, iOS, Python, WebDev, the API, Arduino, articles about explaining the onboarding process, what's going on with each one of the individual sensors, the reference for OAuth, on and on and on. We've done a, in my opinion, pretty darn good job of documentation. It shouldn't be too difficult to get started with the WunderBar. Go back to our presentation. And now the moment you guys have probably all been waiting for. I'm going to try and avoid embarrassing myself while actually coding live in front of you guys. So now we're going to take the time and create a simple WunderBar application. Let me exit this. And our first step is to go to our developer dashboard. Remember, that's at developer.relayer.io. And you would log in with your account if you hadn't already done so. In this case, I am already logged in, so I'll go ahead and skip that step. Our next step is to create a new application. So I'll click New API Key, and I'll call this Webinar. And our description is Virtual IoT Example Application. You don't actually need a description, but we'll toss one in there. So we will specify a redirect URL for the OAuth authorization flow. In this case, I'm just going to make it localhost 8000, and the file I'm going to create is called mainpage.html, and then I'll just go down here and hit finalize. And that should pop up here momentarily. Where is that? Webinar, there we go, down there at the bottom. Great, so our next step, I'll go to that main page.html file. I've already taken the liberty of creating an extremely simple HTML page for that. Sorry about that little mistake there. And all this consists of is a single div called sound level that currently states that there is no microphone connected. And what we're going to do in this example is wire up an application that's going to log us in to get data from our WunderBar and then display the values that are being generated by the WunderBar microphone live inside of that div. So I've got a JavaScript here, the JavaScript tag, and I've taken the liberty of importing the Relayer JavaScript SDK in this highlighted line at the top up here. So the first thing, I've already created a variable that contains the sound level div, so I don't have to type that out and reference it a little bit later. But the first thing we need to do is initialize the Relayer SDK. So I'm going to create another variable, I'll just call it Relayer, equals the Relayer SDK, and we will initialize that. And we need to pass two things. We need to pass an app ID, and that is what we grab from, oh, here we go, down here. We just copy that out of our API keys. Go back to Sublime Text, there we go. So we place that in there, and we also put our redirect URI. We can grab from. Cool. So then once we've initialized our SDK, the next step is to log in. So we'll say relayer.login, and this is going to initialize our OAuth authentication flow. So basically, what the login function does is search inside of our web browser's local storage for a saved token. If it does find one, then it will just immediately redirect us to a method we're going to declare in a second to be executed upon a successful login. And if it doesn't have one, it will redirect us to the Relayer page to actually do the login. So we'll define that success function, and this is going to be a function that takes a token as an argument, and just for fun's sake, at first, we'll just alert the value of that token. Cool, so right now I'm running a Python simple HTTP server, and we'll just go ahead and create a new incognito window and try and run our application here. HTTPS localhost 8000 page.html. Uh-oh, I've done something horribly wrong, haven't I? Oh boy.
I guess you should just remove the HTTPS and do
Yeah,
HTTP
you're probably
instead,
right. Yeah, let me just go ahead and restart my simple server here. Yeah, let me get rid of that bad boy there. There we go. Cool. So we obviously didn't have our login already done. It didn't have a token stored in the browser storage, so you can see it redirected us to our authentication page. So we'll go ahead and log in with my credentials. Okay. Sign in, and goody, something else has gone terribly wrong. Let me figure out what's happening here. This must be with our redirect URI. I've probably set that to be incorrect. Let's change that back to. You have to excuse me, I'm not the JavaScript master of the world here. So. HTTPS localhost 8000 page.html. That should be working fine. Hold on one second, folks. This is always the issue with trying to do these things live, is half the time they tend not to work at all. So let me just finish this right here. Oops, okay. Yeah, I've done something terribly wrong. I know what I did. Let me fix this real quick. Okay, so we got that saved. And go back to it. Okay, that should do it.
Yes.
Let's go back to our screen share here. If I can find what window I'm in. All right. There we go. Cool. And we are back. Let's try and run this one more time. Go back to the login screen. Great. So there it pops up with the token, just like we wanted it to. Once again, I'd like to apologize for that, but hey, at least I'm trying to do it live, right? No fake.
Yeah, that's actually awesome.
Yeah, no problem, guys. You got to do it as legit as possible. It's the true developer experience, making stupid mistakes all the time. I'm the best at it. So we'll take out that alert token, and instead we'll actually start reading data from our device. So we'll start by saying relayer.devices. This gets a list of all our devices, and then we'll say get device data. And get device data is going to, as I say, open up a connection to that device and start streaming values. So we need to pass a couple of arguments to that, one of which is the ID of the device that we're trying to read. So I'll go to sensors, and I'll click on this little gear in the upper right here, which gives us a few pieces of information about our sensor. This is as good as time as any to discuss this screen. Here is a place where you can change the title of your sensor. You can make it public or not, turn on an LED on it just to make sure that it is actually connected and onboarded, and you can also edit the frequency with which your sensor is taking readings. And by default, that's 1 second. You can actually get that all the way down to 5 milliseconds, and as you could imagine, that will greatly reduce or increase the lifetime of your battery. So we'll copy this device ID here because we're trying to get data from the microphone. Go back to here and say device ID equals that value, and then we also need to provide a function to be called every single time that we get a new piece of data. So we call that incoming data, and we define that as a function that takes an object containing the data as an argument, and then we put a semicolon there before I forget to do that. And so inside of this function, all we want to do is update the value of that div, so it's text, with the sound level in that data object, so data.sd sound. Cool. So let's give this a spin and see what happens. Back to the page here. Refresh that. Undefined. Uh-oh. I know what I did. Here we go. Let's get back here and put some E's in there. All right, and there we have it. Actual live data coming out of my sound sensor. I'll start making more noise much closer to it. You can see that value increasing accordingly. So I can't hear any of you guys, but I can only hope that you're giving me a resounding round of applause right now. Let's go back to the slides for a few more, and then we'll take questions. So we'll talk a little bit about our community. We're currently on a website called hackster.io. This is where we're trying to build up a community around the Wonderbar, and it's a place for people to show off their projects. So if you want to see some other really interesting stuff that's been done with the Wonderbar over the last couple of months since we've gone live, you can go to hackster.io and search for the Wonderbar. There's 13 or 14 really interesting projects up there that may give you guys a little bit of inspiration. And again, if you do decide to purchase a Wonderbar and do some cool things with it, we'd love to see the projects that you guys make up there on Hackster. And then the other interesting thing is open source. We're very strong believers in open source. We're going to open source all of our SDKs, and we're even going to open source our hardware itself. So we're currently developing the last version, or we're currently developing a finalized version of our firmware. We're going to make that open source once it's finished, and then we'll actually publish, or they may already be published, the actual specs for the PCB, the circuitry, the chips and everything on board these Wonderbar sensor modules. So if you decide to, something you want to do, you can download those specs, tweak them any way you want, and create literally your own Wonderbar. If you want to make it on a flexible circuit board or in a specific form factor, that's completely up to you, and we're just excited to see all the new IoT applications that get developed with really cool new open source technology. So finally, we'll just do one quick little plug. We're hiring. If you love doing cool things with IoT, go ahead and shoot me an email and we can talk about that kind of thing. And my contact information is peter@relayer.io. I'd love to hear from any of you about any questions you might have about Relayer or the Wonderbar. And once again, I'm Peter Dvestek. It was a pleasure talking with you guys. So let's have some questions, huh?
Thanks, Peter. Great job with the live demo. That was actually quite impressive. So I was wondering, I have a first question. You showed the box on Thingiverse. I was wondering if people are looking at printing using real chocolate. That would be pretty fun, right?
I mean, yeah, you certainly could, but you're going to run into the issue of somebody actually biting into that, and that'd be no fun. I haven't bitten full force into a piece of PCB before, but I can't imagine my dentist is going to be happy with me. But yeah, man, if you want to print chocolate for it, it's completely up to you.
Yeah, I might try that. We have a few questions. A few questions regarding the sensors. Jorg is asking what one can use to extend the sensor modules. I guess you probably answered that with the Grove connector, right?
Yeah, but we'll talk a little bit more about that. So, I mean, let me just unplug it so I can hold it more easily in front of the camera. So the module we have there, front and center, is what we call the bridge module, and it has this connector here that you're able to do serial communication over. So there's a family of sensors made by a company called Seed Studios called the Grove family that have connectors that match up exactly with that, so you can just plug one of those in and go. And that has things like, I mentioned a few examples like breathalyzers, poisonous gas detection, soil. I'm playing soil moisture. I'm playing around with a barometer right now for some interesting snowboarding applications. We'll see what I can do with that. And then you can also just use this for direct serial communication with really anything. So we have a library already for the Arduino where you basically just plug the bridge module into the Arduino's hardware serial, and you can do two-way communication between it. So really, really exciting expandability stuff with that module.
Cool. And regarding the accelerometer, Mike is asking us how many degrees of freedom the accelerometer has, and if the signal is like noise filtered and like a very clean signal for really allowing nice use of the accelerometer.
Right. So the accelerometer and gyroscope together makes a 6-axis system. So it's a 3-axis accelerometer combined with a 3-axis gyroscope, and we don't do a ton of signal filtering on our side. We more or less leave that up to you guys to decide how you want to pursue that. It might be better for some people who don't care that much to not have any, and people that care a lot more can really crank up the sampling rate and do some filtering on their own. So not a ton, but it is a quality sensor.
And so if I understand the programming model correctly, the signal processing would be done in the final application. I mean,
Correct.
You don't really program the microcontroller, right?
You are free to. I mean, if that's what you'd like to do, I mean, we'll make the firmware public, and you can edit it in whatever way you want. So if you do really want to do any kind of processing on the chip, that's completely up to you guys. But as it stands right now, we're really all about just getting the data into your hands and giving you the freedom to do whatever you want with it.
Okay, that's cool. Another question regarding the connectivity. So you can connect using Wi-Fi, and can you as well maybe share the connection from your mobile phone and get the internet connectivity via Bluetooth, or?
Well, yeah. For example, as we said, there's two ways to connect to it. You can just use the Wi-Fi chip over Wi-Fi stream data to your phone through the cloud wherever you are. You know, you could be halfway around the world from your sensors, and you'd still get that data. But if you're in much closer proximity to your sensors, you can just create a direct Bluetooth connection between the phone and the sensor module. And then, I mean, once you have the internet connection on your phone, you can send that data wherever you want.
Correct, yeah. Okay. In the JavaScript demo that you did, the data that you get in the web application, is it retrieved over MQTT?
In the demo that we did there?
Yeah.
The web browser in its current state still uses the pubnub, but
Okay.
the developer, who I can actually see from where I'm sitting right now, is currently working on an MQTT version using JavaScript.
Okay, I see. Cool. And so, can you remind us what are the other APIs? There's JavaScript, Node.
Yeah, we have JavaScript, Node, Android, iOS, and Python are the big ones we've got right now.
Cool.
Yeah.
So I think we have one last question.
Cool.
Will we see the WunderBar open firmware before Christmas?
Oh, I mean, what day is it today? Today is the 16th? Oh, before Christmas is probably pretty unlikely, but within shortly after the new year, I'd say would be much more likely. It's definitely it's very, very much nearing completion.
Okay, cool. I don't think we have any more questions. And thanks so much for the presentation.
Yeah, you're welcome,
so
guys.
can you remind us where people should go if they want to learn more?
Oh, yeah, that's probably a pretty good idea, huh? Well, there's two good access points. Our main site is www.relayer.io, and then the developer site, or the dashboard that I showed you, was developer.relayer.io.
Okay, perfect. So I do have one last general announcement. In case you haven't seen, we are organizing an Internet of Things challenge for which we take applications until mid-January. So make sure to check out iot.eclipse.org/Open IoT Challenge. And yeah, basically we want people to use open source technology to build nice IoT applications. So of course, MQTT, Eclipse IoT project would be an option. I'm sure you can do some great things using the Wonderbar as well. So make sure to check out the website and apply with the online form. And with that, I thank you again, Peter. I think there are a few other questions that showed up on Twitter. So maybe you, we can take the discussion offline and
we can take a. Yeah, if they're quick, I can totally take a crack at answering them now.
So the question was, how common is BLE on smartphones? Are all new Android phones enabled, or any quick list of phones that are supporting BLE?
All the new ones should definitely have it. Some of the older ones, I mean, cheaper phones made within the last year or two, maybe not, but any new modern phone should definitely have it. The development phone that we use is the Nexus 5, and that absolutely has it enabled. So your mid-range of phones and up created within the last year or so should definitely have BLE.
Yep. Okay, cool. So yeah, I think this time we're really out of questions. The webinar is recorded. Feel free to comment on YouTube if you have any more questions. They will be answered there.
Great.
Thanks, Peter.
Yeah, go ahead and shoot me an email if you have any questions, guys. Thanks for having me.
Thanks.